Hello everyone and welcome back to our channel. Today we dive into the world of PySpark to explore the weird function and easy and powerful way to filter your data frames just like you would with SQL. If you're familiar with the where clause in SQL, you'll feel right at home as we look at how PySpark lets you apply similar logic to filter rows efficiently. Whether you're new to PySpark or just looking to enhance your skills, this video will guide you through everything you remember about SQL-like filtering in PySpark. So let's get started. Introduction to the where function. The where function in PySpark is a powerful tool used for filtering rows in a data frame based on a specified condition. It works in a way very similar to the where clause in SQL, allowing you to easily apply logical conditions to narrow down your data. Essentially, the where function is identical to filter function in terms of functionality. The main difference lies in its more SQL-like syntax, which makes it particularly convenient for users who are comfortable with SQL queries. With where you can filter out rows that do not meet specific criteria, making it easier to work with only the relevant subset of data. This is especially useful when working with large datasets as it helps in refining the data and focusing on just the rows that match condition you're interested in. Whether you're checking numerical values, matching strings, or combining multiple conditions, the where function provides a familiar and intuitive way to handle the filtering in PySpark. Basic syntax. Sha, the basic syntax for using the where function in PySpark is DataFrame.where condition. In this syntax, the condition represents any valid PySpark SQL expression evaluates to either true or false. The where function then uses this condition to filter the rows in the data frame. Only the rows that satisfy the condition, i.e., where the condition evaluates to true, are kept in the resulting data stream while the others are discarded. The condition can be as simple or as complex as needed, ranging from straightforward comparisons of column values to more advanced expressions involving multiple columns, uh, arithmetic operations, or logical operators like and, or, and not. This flexibility allows you to precisely control which rows are included in the filtered data frame. Whether you want to match specific values, apply numerical comparisons, or combine multiple conditions, the where function provides a simply yet powerful way to refine your data, making it easier to work with just the rows that meet your requirements. Why use where? Although where and filter are interchangeable in PySpark and provide identical functionality for filtering rows based on conditions, there are certain reasons why some developers prefer using where. One of the key reasons is its SQL-like syntax consistency. For developers who come from an SQL background or frequently work in SQL-based environments, UL feels more intuitive and natural because it aligns with the familiar where clause would be in traditional SQL queries. This consistency can make it easier to read, understand, and maintain the code, especially when working on projects that involve both SQL and PySpark code. Additionally, when writing complex data processing workflows that involve a lot of SQL-like operations, the use of where can help maintain a consistent style throughout the code. This can be particularly useful for developers transitioning from SQL-based data environments to PySpark, as it provides a smoother learning curve and ensures that the code remains comprehensible. Using where can make the PySpark code look more query-driven, which can be helpful in collaborative projects where team members are more familiar with SQL syntax. Overall, the choice between where and filter often comes down to personal preference and a desire for syntax consistency, but both functions are equally capable when it comes to filtering data frame rows effectively. Practical examples. 1. Basic SQL-like filtering. In this example, we are working with a PySpark data frame that contains employee information, including columns for employee underscore ID, name, and salary. We start by creating the data frame using the create data frame function and provide a list of tuples that represent individual employee records where each tuple contains the employee's ID, name, and salary. The columns are labeled appropriately to give a structured and meaningful representation of the data. To filter the data frame, we use the where function to apply a SQL-like filter condition. Specifically, we use salary 3000 as the condition to retain only those rows where the salary is greater than 3000. This syntax closely mirrors how conditions are applied using the where clause when JUvas in SQL, making it straightforward for developers who are familiar with SQL to understand and use. The where function filters out the rows that do not meet this condition, keeping only those employees whose salaries are above 3000. Finally, we call the .show method to display the filtered data frame, which will include only the employees Jane and Tom, both of whom have salary greater than 3000. Using the where function with SQL-like conditions helps maintain readability and makes the filtering process feel more natural for those who are used to it with databases and SQL queries. This allows you to effectively refine your data and focus on just the rows that meet the required criteria. 2. Filtering using multiple conditions. In this example, we are working with a PySpark data frame that contains information about employees, including employee underscore and score name and salary. We start by creating the data frame using the create data frame function and provide a list of tuples where each tuple represents an employee's details such as their ID, name, and salary. This structured data helps us perform specific analysis and transformations as needed. We use the where function to filter the rows based on a specific salary range. Here we specify the condition salary 3000 and salary 4000 to keep only those rows where the salary falls between 3000 and 4000. The condition is provided as a string, which makes it very similar to how conditions are written in a SQL where clause, providing a familiar feel for those accustomed to SQL queries. The use of AND helps combine two conditions, ensuring that only the rows that meet both criteria are retained, those with a salary greater than 3000 and less than 4000. Finally, we use the .show method to display the filtered data frame, which will only include employees whose salaries fall within this specified range. In this case, only the employee named Tom meets the criteria with a salary of 3500. Using the where function in this way is particularly effective when working with specific numerical ranges or when applying multitions to filter data. It keeps the filtering process simple and readable, making it easy to understand which subset of data you are working with. This helps ensure you are focusing only on the most relevant records for your analysis or processing tasks. 3. String-based filtering. In this example, we are working with a PySpark data frame containing employee information, including columns for employee underscore ID. We start by creating the data frame using the create the data frame function and provide a list of tuples that represent employee records, with each tuple containing the employee's ID, name, and salary. This structure allows us to easily manipulate and analyze the employee data. To filter the data frame, we use the where function with the SQL-like condition to find employees whose names start with the letter J. Specifically, we use the condition name like J% to achieve this. The like keyword is commonly used in SQL to search for patterns in string columns, and in this case, the pattern J% is used to match any name starts with the letter J. The percent symbol acts as a wildcard, allowing any sequence of characters to follow the letter J. This is a convenient way to filter text data when you want to match specific prefixes or patterns. We then call the dot show method to display the filtered data frame, which will include only those employees whose names start with J. In this example, the employees named John and Jane meet the condition. Using the where function with the like operator allows you to effectively filter text based data in a way that feels familiar to SQL users. It makes working with string pattern intuitive, enabling you to quickly extract the subset of rows that match your desired criteria, especially when dealing with names, identifiers, or other text fields. 4. Filtering using multiple columns. In this example, we are using PySpark to work with a data frame that contains employee information, including columns for employee underscore year, name, and salary. We create data frame using the create data frame function, providing a list of tuples representing the employee records. Each tuple includes the employee's ID, name, and salary, which are organized into columns for easy access analysis. To filter the data, we use the where function along with the SQL-like condition narrow down the rows based on two criteria. The condition salary 3000 and name like T percents used to select only those employees who have a salary greater than 3000 and whose name starts with the letter T. The AND operator is used to combine these two conditions, meaning both must be true for a row to be included in the result. The like operator paired with the pattern T percent is used to match any name that begins with letter T, with percent acting as a wildcard that allows any sequence of characters to follow. Finally, we use the dot show method to display the filtered data frame, which will contain only the rows that satisfy both conditions. In this case, only the employee named Tom, who has a salary greater than 3000, will be included in the result. This example demonstrates the power of using SQL-like conditions in the where function aligned for complex filtering involving numerical comparisons and string pattern matching. It makes it easy to precisely select the subset rows that meet specific criteria, enabling you to focus on the most relevant data for your analysis. 5. Filtering null and not null values. In this example, we are working with a PySpark data frame named diff underscore with underscore null, which contains employee information such as employee underscore name and salary. It creates the data frame using the created data frame function, providing a list of tuples where each tuple represents an employee's details. Some of the employees have missing salary information, which is represented by none in data, indicating that the salary is null. This scenario is common in real-world datasets where not all fields may have complete information. We use the where function to filter the data frame based on whether the salary is null or not. First, we use the condition salary is not null to filter and retain only those rows where the salary value is present, i.e. not null. This allows us to exclude any records with missing salary information, which is often necessary when we want to perform calculations or analysis that require complete data. The dot show method is used to display the resulting data frame, which includes only the employees John and Tom, as they both have non-null salary values. Next, we use the where function with the condition salary is null to filter and select only those rows where the salary value is missing. This helps us identify the incomplete records that may need special handling, such as imputation, correction, or exclusion from analysis. The dot show method is used to display the filtered data frame, which will contain pertinently employee Jane, whose salary value is null. These examples demonstrate how PySpark makes it easy to work with incomplete data by providing functions like is null and is not null within the where function. These SQL-like conditions help you filter rows based on the presence or absence of values, ensuring that you can effectively manage missing data, whether by excluding it from your analysis or by identifying it for further processing. 6. Combining SQL-like filtering with expressions. In this example, we are working with the PySpark DataFrame BF that contains employee information, including columns for employee underscore ID, name, and salary. We create this data frame using the create data frame function, which helps us organize the data in a structured format, making it easy to perform various operations on it. To filter the data, we use the where function with a SQL-like condition that involves an arithmetic operation. Specifically, the condition salary 1.1 3,500 is used to filter rows based on the result of multiplying the salary by 1.1. This operation effectively represents giving a 10% salary increase to employee. The condition then checks if the resulting value is greater than 3,500 and retains only those rows where this condition is met. Using the .show method, we display the filtered data frame, which includes only the employees whose adjusted salary after the 10% increase exceeds 3,500. This kind of filtering is particularly useful when you need to perform dynamic calculations as part of your filtering criteria, allowing you to apply transformations to column values and filter the results in a single step. This SQL-like syntax makes the code more readable and intuitive, especially when performing complex operations, as it closely resembles traditional solution with special expressions. It's a powerful way to extract only the rows that meet both the calculated and logical requirements, making your data processing more efficient and insightful. 7. Using where with PySpark expressions. In this example, we are working with a PySpark data frame div that contains employee information, including columns for employee underscore id, name, and salary. We create the data frame using the create data frame function, probing employee data in a structured format, which makes Bond easy to manipulate and analyze. To filter the data, we use the where function in combination with PySpark's call function to specify conditions. We start by importing call from PySpark.clot functions, which allows us to reference columns in a more programmatic way. In this example, we use call salary to refer to the salary column and apply two conditions: call salary 3,000 and call salary 4,000. These conditions are combined using the AND operator, which means that both conditions must be true for a row to be included in the filtered result. Essentially, we are selecting employees whose salaries are greater than 3,000 but less than 4,000. The .show method is then used to display the filtered data frame, which includes only those employees whose BRD get. By using call, we make the filtering process more flexible and readable, especially when working with larger and more complex data frames. It allows for dynamic references to columns, making the code easier to adapt and reuse. This approach is particularly beneficial when writing PySpark code that needs to be maintained or extended, as it keeps the column references consistent and clear, helping to avoid errors that might occur with manual string based column names. Thanks so much for watching. I hope you now feel more comfortable using the where function in PySpark for SQL-like filtering in your data frames. It's a simple yet powerful tool to narrow down your data and make your analysis much more efficient. If you enjoyed this video, make sure to give it a thumbs up, subscribe to the channel for more PySpark tutorials, and drop your questions or thoughts in the comments below. I'd love to hear from you. Until next time, happy coding.